Hey there, and welcome to our Explainer. Today, we're diving deep into one of nature's most powerful and awe-inspiring forces, the typhoon. We're going to look at the very specific recipe that brings them to life, figure out how we measure their incredible fury, and we'll even get into the stories of the biggest, baddest storms ever recorded.
So, to really get a grip on the kind of power we're talking about, let's start with a really chilling piece of history. Back in 1975, Typhoon Nina hit China. The storm dumped so much rain so fast that it caused this catastrophic chain reaction of dam failures, which unleashed what was basically an inland tsunami. The death toll was just staggering. This is the raw power of a typhoon, and it's exactly why we need to understand them.
Okay, so a storm with that kind of destructive power really makes you wonder, what is a typhoon exactly? What makes it different from a hurricane or any other big storm we hear about? Well, it really just boils down to two things: where it's born and just how strong it gets.
So at its core, a typhoon is a tropical cyclone, but it has to form in a very specific place, the northwestern Pacific. And it has to have sustained winds that hit at least 119 kilometers per hour. But here's the wild part. This one patch of ocean is basically the planet's storm factory. It churns out almost a third of all the world's tropical cyclones.
So, what's in the special recipe that cooks up such a monster storm in this part of the world? Well, it's not simple. It's a really delicate mix of atmospheric ingredients that all have to come together in just the right way.
Yeah, you can think of it like a checklist. First, you need really warm ocean water. That's the high-octane fuel for the storm's engine. Then you need an unstable atmosphere and tons of humidity, which provides all that rising moist air to build the storm structure. Next up is the Coriolis force. That's the spin of the Earth, the secret sauce that gets the whole thing rotating. Then you need a little something to get it started, a pre-existing weather disturbance. And finally, you need low wind shear, so that the storm can grow vertically without getting torn apart by winds at different altitudes.
All right, so once one of these storms spins up, how do we actually measure its strength? Because, not all typhoons are created equal. Forecasters have a very specific scale they use to classify just how intense these things are.
So this is the official playbook they use in the region. A storm starts out as a pretty humble tropical depression. As it gets stronger, it gets a name and becomes a tropical storm, then a severe tropical storm. And once its winds hit that magic number, 119 kilometers per hour, boom, it officially becomes a typhoon. But as you can see, it doesn't stop there. The scale goes all the way up to violent typhoon, for the absolute most destructive storms you can imagine. Now, here's a little inside baseball for you. Ever wonder why you might see different wind speeds reported for the same storm? Well, it all comes down to how you count. The official Japanese agency, the JMA, averages the wind speed over a full 10 minutes, which kind of smooths out the peaks. But the American agency, the JTWC, uses just a 1-minute average, which is going to catch those stronger, shorter bursts of wind. So the US numbers will almost always look higher. The key thing to remember, neither is wrong. They're just speaking slightly different languages.
Okay, so we've covered the how, but what about the where and the when? Let's take a look at the typical patterns these storms follow.
And I've got to say this again because it is so important. The northwestern Pacific is hands down the most active storm basin on the entire planet. They call it Typhoon Alley for a reason. And unlike the Atlantic, which is a pretty defined hurricane season, this place is open for business all year round, though it definitely has a peak season.
And you can really see the rhythm of the season right here. I mean, look at that. February is the quietest month, for sure. But from there, it's just a steady climb until the activity absolutely explodes in the summer and fall. The peak is in August, which averages more than 5 named storms in that 1 month alone. Incredible. So you do the math, and what do you get? On average, the region gets nearly 27 named storms and typhoons every single year. That is a huge number, and it really gives you a sense of the constant threat that millions of people in this part of the world live with. Now, these storms, they don't just wander around aimlessly. Their paths are usually controlled by this giant atmospheric steering wheel called the subtropical ridge. Think of it like a massive area of high pressure that acts like a wall. And depending on where that wall is, typhoons usually get forced into one of 3 main tracks: a straight shot west, a big curving path up towards the north, or a more direct route straight north over the open ocean.
We've all heard storm names like Hurricane Katrina or Andrew, but typhoons are named completely differently. They use this really unique and collaborative international system that's pretty cool.
Yeah, instead of a list of human names like we see in the Atlantic, the typhoon naming system is this really fascinating international project. 14 different countries and regions all contribute names to one big master list. And these names aren't for people, they're for things like animals, flowers, or famous landmarks. That's how you end up with a name like Koinu, which is Japanese for puppy, or Bulawan, named after a plateau in Laos. The one main exception here is the Philippines. They have their own separate list of names that they use for storms in their area.
All right, now for the main event. Let's talk about the outliers, the absolute monsters. These are the record-breaking storms that push the limits of what meteorologists even thought was possible.
So first up, let's talk about the one metric everyone thinks of, pure raw wind speed. What's the fastest we've ever reliably seen?
That terrifying record belongs to Typhoon Haiyan back in 2013. Just before it slammed into the Philippines, its sustained winds, now we're not talking about gusts, we're talking about its constant, non-stop wind speed, were estimated at an unbelievable 314 kilometers per hour. That's 195 miles per hour. And this wasn't some reading way out in the ocean, this was the force that was about to hit populated islands. Just devastating.
But you know, wind isn't the only way to measure a storm's power. Another critical indicator is its central pressure. And with these storms, the lower the pressure, the stronger the storm.
And the all-time champ here is Typhoon Tip from 1979. At its peak, it reached a minimum central pressure of just 870 hectopascals. Now, to put that in perspective, normal pressure at sea level is around 1,013. Tip was an absolute monster, and it still holds the record as the most intense tropical cyclone ever recorded anywhere on Earth.
Okay, so we've got wind, we've got pressure, but what about the rain? I mean, the sheer volume of water these storms can dump is unbelievable. So who holds that record?
That unwelcome title belongs to Typhoon Morakot in 2009. It basically stalled out over Taiwan and just unleashed a historic deluge, dropping over 2,300 millimeters of rain. That's more than 91 inches. That's over 7.5 feet of rain. From a single storm, it just shattered every rainfall record that ever existed.
And that brings us to a final, really critical question. We've just looked at the historical records for wind, for pressure, and for rain. But in a world with warming oceans, which is the very fuel for these natural engines, are these records truly history, or are they just the records, for now, waiting to be broken? It's a pretty sobering thought. Thanks for joining me for this explainer.